Let's start by introducing the SDET role. Simply put, an SDET is a software development engineer who specializes in testing. They are not just running tests, they are building automated test systems that developers can use throughout the entire development lifecycle. Think of them as testers with strong programming skills responsible for creating and maintaining the tools that ensure software quality. They work closely with developers and other teams to build a robust testing strategy, including things like performance and security testing. Okay, so let's talk about how these roles often get mixed up. Think of QA engineers as the folks who are primarily focused on finding bugs through manual testing and ensuring processes are solid. They are experts in writing detailed bug reports and figuring out how to improve testing overall. Then you have test automation engineers. They concentrate on building those automated tests themselves, making sure they run smoothly and reliably. Finally, the SDET is a bit of a superstar. They are not just testers or developers, but they bridge the gap by designing the whole automation architecture, integrating tests into our continuous integration pipelines, and collaborating closely with developers to build quality right. And from the beginning, it's about building tests into the software. Let's talk about how SDLC and SDLC relate to being a software development engineer in tests, or SDET. The SDLC is essentially the roadmap for building any piece of software. It's that whole process from starting an idea all the way through to delivering a finished product and keeping it running smoothly over time. Think of it as a series of steps: gathering requirements, designing how things will work, coding, testing, deploying, and then ongoing maintenance. Now SDLC takes this a step further. It's really just SDLC with a strong emphasis on testing. SDETs are the champions of that testing focus, making sure quality is baked in at every stage, not just tacked on as an afterthought. Let's talk about the SDET role and how it's transforming. Traditionally, testing was seen as a separate phase, but now SDETs are deeply embedded in development teams. Think of them as quality champions. Agile methodologies have shifted this, emphasizing rapid iteration and collaboration. Within Scrum, SDETs work alongside product owners to ensure we're building the right thing, and then they automate tests so these changes can be rolled out quickly. And when you add DevOps into the mix, SDETs become critical for automating our build and deployment processes, making sure everything runs smoothly and reliably. Okay, let's talk about the foundations of successful test automation. It's really about building a smart system, not just throwing code at it. We start with the test pyramid, which suggests that you want fewer, but more thorough tests at the top, things like automated UI interactions, and then a growing number of smaller, focused unit and integration tests as you go down. DIY is huge. Don't repeat yourself in your automation. It makes maintenance a nightmare. Think about test-driven development. Writing the test before you write the code helps you think about what needs to be tested first. And finally, always keep maintainability top of mind. Clean, well-named tests are far easier to work with over time. Don't forget good logging and using version control for your scripts. Automation is a tool to help us test better, not replace our testers. Okay, let's talk about designing a test automation framework. Think of it as building the foundation for all your automated tests. It really helps keep things organized and reusable. A good framework includes things like individual test scripts, which are the actual code that performs actions, and the page object model, or POM, which is a fantastic way to represent user interface elements so you don't have to repeat yourself when writing tests. It also needs data management. How will your tests get their information? And of course, reporting and logging. We need to know what's happening during testing. Let's break down the different types of frameworks. Data-driven, which uses external data sources like spreadsheets or CSV files. Keyword-driven, where you define keywords for actions, and hybrid approaches that combine these. The best choice will really depend on your project-specific needs. Okay, let's talk about test frameworks. As an SDET, you'll need to understand a few different approaches. We've got data-driven testing, where tests are built around external data, really handy for large datasets. Then there's keyword-driven, which uses keywords to represent actions within your test. This makes them super modular and reusable. Hybrid frameworks combine the best parts of these two. Behavior-driven development focuses on defining why a test needs to run, using plain language, and that really helps with collaboration. And finally, the page object model POM is a brilliant way to organize your UI elements into reusable objects, making tests more stable and easier to maintain. Okay, so the slide is all about Selenium WebDriver. It's essentially a remote control for web browsers. Think of it as giving your computer the ability to click buttons and fill out forms on websites automatically. We'll talk about what the core components are, like the WebDriver driver itself, how Selenium Grid can help you run tests faster, and the general flow of how you use it, from initializing the driver to navigating a page, interacting with elements, and verifying that everything worked as expected. It's a really powerful tool for automating testing. Okay, let's talk about how Selenium WebDriver actually works. At its heart, it's a client-server system. You start with a Selenium IDE or your own written test scripts. That's the client sending commands. Then a central piece called the WebDriver server handles all the communication. This server speaks to specific browser drivers, like Chrome driver for Chrome or Gecko driver for Firefox. These drivers then translate those commands into actions the browser understands, essentially telling it what to do: click buttons, fill in forms, you name it. It's a layered approach that makes automation really powerful and flexible. Okay, let's talk about locators in Selenium. They're the key to telling Selenium exactly where to find things on a web page. Think of them as addresses for elements. We have several different ways to do this, and each has its strengths and weaknesses. The most reliable is usually the ID if an element has one. XPath is incredibly flexible but can get complicated if the website's structure changes frequently. CSS selectors are often a good balance between efficiency and readability, and we'll look at a few examples in this table to illustrate how they work. Okay, let's talk about handling those tricky dynamic web elements. These are the things on your web page that change, maybe a shopping cart updates as you add items, or a form changes based on your input. As an SDET, it's crucial to know how to test these. We can use tools like Mutation Observer in JavaScript to watch for direct DOM changes. But often, those changes are happening through AJAX requests. So we need waiting strategies, things that tell our tests to pause and wait until the element is actually ready before we try to interact with it. Don't rely on fixed locators, they'll break. Also, think about how your tests behave when new content loads from a server. And don't forget shadow DOM. It can make testing a bit more involved, so be sure you understand how it works. Okay, so let's talk about frameworks for automated testing. JUnit is a really solid starting point. It's the original unit testing framework for Java. It's fantastic for verifying small pieces of code in isolation. Think of it as building your tests from individual bricks. Then comes TestNG. It's like an upgrade to JUnit, adding tons of extra power and flexibility. Things like running tests at the same time, parallel execution, are much easier with TestNG, which can drastically speed up your testing process. And its data handling is way more sophisticated thanks to features like it data provider. Basically, TestNG offers a lot more control and detailed reports than JUnit does. Let's break down some key differences in this table. You'll see how TestNG really expands the possibilities for automated testing. Okay, let's talk about speeding up our tests. Parallel and distributed execution are powerful techniques that SDETs use to get faster feedback. Basically, parallel execution means running multiple tests at the same time on a single computer. Think of it like having multiple lanes on highway for your tests. Distributed execution takes this even further by spreading those tests across several machines, which is fantastic when you've got a huge test suite or a really complex project. It gives us faster feedback loops and makes our testing process much more scalable. Okay, so let's talk about how we can make our tests much easier to manage. We're going to cover the Page Object Model, or POM. It's a really popular design pattern for test automation. Essentially, POM helps us model each web page or screen in our application as a separate object. Think of these objects like blueprints for specific pages. We also use something called Page Factory, which is basically a tool that simplifies the process of finding those elements, things like buttons and text fields on a page, by automatically generating the code to find them, so we don't have to write all that out ourselves. Okay, let's talk about two really effective ways to automate testing: data-driven and keyword-driven approaches. Data-driven testing is all about separating your test cases from the actual data you're using. Instead of hard-coding values into your tests, you pull them from things like spreadsheets or databases. This makes it super easy to add new scenarios, and changes are much simpler. Think about testing a registration form. You'd easily use data-driven to try different names, emails, and passwords without rewriting the entire test script. Then we have keyword-driven testing. This method focuses on creating reusable keywords that represent actions like login, search, or add to cart. These keywords are then organized in a table along with the data they need, so you're basically building a recipe for your tests. This makes them much easier to maintain, and different people on the team can collaborate more effectively. Okay, let's talk about behavior-driven development. Think of it as a way to make sure we're building software that actually does what our users need. BDD is all about collaboration: developers, testers, and business folks working together. It starts with writing user stories in a really clear, easy to understand language called Gherkin. Essentially, you're describing how the system should behave using given, when, then steps. Next, we automate these scenarios to create something that can be executed as tests. And finally, we run those automated tests and make sure everything behaves according to our specifications. It's a really powerful way to build quality software. Okay, let's talk about how software development engineers and tester SDETs use Gherkin and Cucumber. Gherkin is a really simple language designed for writing acceptance criteria, basically describing what the software should do from the user's perspective. Think of it like translating business requirements into clear steps that everyone can understand. Cucumber is then a tool that takes those Gherkin scenarios and turns them into actual automated tests. It works with frameworks like Selenium or Rest Assured to make sure the code meets those expectations, really connecting the world of business and technology. Okay, let's talk about API. They're the backbone of many modern applications. Basically, an API is like a set of instructions that allows different software programs to talk to each other and share information. Testing these APIs is super important because it ensures everything works correctly behind the scenes. We have two main types: REST and SOAP. REST is a simpler approach. Think of it like using standard methods like get, post, put, and delete to access data. It's lightweight and very popular. Then we have SOAP, which is more complex, uses XML for messaging, and relies on WSDL files to describe the API. Understanding the differences between these two will help you build robust and reliable applications. Okay, let's talk about how we automate APIs as SDETs. We've got some fantastic tools to choose from. First up is Rest Assured. It's a Java library that makes building and running tests really easy. Think of it like a streamlined way to send requests and check the responses. Next, we have Postman, which is super popular because it has a visual interface. It's great for quickly exploring API and creating test scripts using JavaScript. And finally, there's Garrote. This tool builds on Rest Assured and is perfect if you want to use behavior-driven development with Cucumber. It helps us write tests that clearly describe what we expect from our API. Okay, let's talk about building a solid foundation for your API testing as an SDET, specifically creating an API framework. Think of this like designing a toolkit. You want everything organized and ready to go. First, you'll need to pick a framework. Rest Assured is a popular choice if you're working with Java. Supertest is great for JavaScript, and PyTest requests works well with Python. Next, it's vital to clearly define your API contracts, basically the blueprints of how API should behave. Using something like OpenAPI or Swagger helps ensure everyone understands what to expect from each request and response. Then, you'll craft reusable test cases covering things like logins, data validation, and error handling. Don't forget about managing your test data. Generating realistic datasets makes testing more effective. Finally, Make sure your framework includes robust reporting so you can easily track results and spot any issues and use assertions to verify those expected outcomes. A good framework saves time and improves the quality of your tests. Okay, let's talk about testing in a world of microservices. These are independent services that work together to make an application, and because they are loosely coupled, they can sometimes cause problems when integrated. That's where contract testing comes in. It's like making sure everyone involved understands the rules of communication, so you don't end up with mismatched data or unexpected errors. Basically, services agree on what data to send and how it should be received, and we use tools like PAC to verify that agreement automatically. Okay, let's talk about service virtualization and mocking. As an SDET, you're going to encounter situations where it's difficult to test your code against real-world services. Maybe they're down for maintenance, too slow, or just unreliable. That's where tools like WireMock and Mountebank come in handy. WireMock is a simple HTTP mock service essentially. It intercepts requests and provides you with predefined responses. Mountebank builds on this by offering a much more robust platform for simulating complex scenarios, including routing requests and transforming responses. Think of it as a complete service virtualization tool. This table highlights some key differences between the two. They both are great tools to help us test our applications effectively. Okay, let's talk about performance testing, a really important part of the SDET role. Basically, we need to make sure our software doesn't break down when lots of people are using it at once. There are a few popular tools that SDETs use like JMeter, Gatling, and K6. JMeter is a classic, Gatling is super powerful for simulating complex scenarios, and K6 is really easy to integrate into your development workflow. We'll want to track things like how long it takes for requests to come back, response time, how much data we're handling, throughput, and what percentage of requests are failing. That's the error rate. Also, keeping an eye on CPU and memory usage is key. Okay, let's talk about security testing for SDETs. It's a really important part of the job, and it goes way beyond just making sure things work. We need to think about protecting users and the system from threats. There are a few key pillars we can focus on: authentication and authorization, ensuring people are who they say they are and have access only to what they're supposed to. Input validation, making sure all data coming into the application is clean and safe. Preventing things like SQL injection or cross-site scripting attacks. Vulnerability scanning, using tools to automatically find common weaknesses. And finally, penetration testing, which simulates real-world attacks to see how resilient our system actually is. Security isn't a one-and-done thing, it's always evolving, so continuous testing and vigilance are key. Okay, let's talk about mobile test automation. As an SDET, you might find yourself working with apps on various devices and platforms. That's where frameworks like APM, Espresso, and XQtest come in. APM is super versatile. It can handle native, hybrid, and web apps all the same way. Espresso is Google's fast and effective solution for Android testing. And then there's XQtest, Apple's tool tailored specifically for iOS development. Okay, let's talk about getting your software out there, really asterisk there. As an SDET, it's not enough just to test on your own computer. We need to think about all the different places where people are going to use our app or website. That means testing across a huge variety of devices, phones, tablets, and different desktop computers. And it's not just about the device. We also need to consider which browsers they're using: Chrome, Firefox, Safari, Edge. They all render things slightly differently. Finally, there are operating systems like Windows, macOS, Linux, iOS, Android. Each presents unique considerations. To help with this, a browser matrix is super useful, basically a table that shows you exactly what versions of browsers work well with different operating systems. And don't worry about setting up all those environments yourself. Cloud-based testing services can give you access to a huge range of devices without the hassle. Okay, so let's talk about how we can really scale our testing efforts with Selenium Grid, Browser Stack, and Sauce Labs. Selenium Grid is essentially a way to spread out your tests across multiple computers instead of just one. This means they run in parallel, which cuts down on testing time dramatically. Now, Browser Stack and Source Apps are cloud-based services that give us access to a huge range of browsers: Chrome, Firefox, Safari, Edge and operating systems, all without needing to buy and maintain our own physical machines. It's like having a massive virtual test lab at your fingertips. These platforms really simplify things, letting us quickly set up and run tests across this diverse landscape. Okay, let's talk about CI/CD and how Jenkins, Azure DevOps, and GitLab CI play a role. Think of continuous integration as constantly merging code changes and running automated tests to catch issues early. Continuous delivery then takes those tested builds and smoothly releases them often automatically. Jenkins is the engine that kicks off these pipelines. You'll also find similar functionalities in Azure DevOps, which offers a really strong suite of tools, and GitLab CI, especially if your team already uses GitLab. The basic flow involves code changes triggering a build, then automated tests being run, and finally results being reported back to the team for quick feedback. Okay, let's talk about version control. As an SDET, you'll be using it a lot. Basically, it's a system for tracking changes to your test scripts and ensuring everyone on the team is working with the latest, most stable code. It is the core technology behind many of these systems. It's a distributed system, meaning each developer has a complete copy of the repository. Then we have platforms like GitHub, GitLab, and Bitbucket, which provide web interfaces for hosting your Git repositories and making collaboration easier. Think of them as places to store and share your code. Each platform offers slightly different features and integrations, so it's worth exploring what might be best for your team's needs. Ultimately, version control is all about teamwork. You can have multiple people working on the same test code simultaneously without messing things up. Okay, let's talk about build tools and specifically Maven and Gradle. These are essential for any SDET because they automate the entire process of building our software. Maven is a really well-established tool that uses something called a POM file. It's like a recipe for your project. You tell it what you need, and it handles everything else. Gradle, on the other hand, offers more flexibility. It lets you customize things in a much more detailed way, though it might take a bit longer to learn. They both handle dependencies and running tests automatically, which is huge for efficiency. Okay, let's talk about databases. As an SDET, you'll be working with them at ***. Databases are the core of many applications, so it's really important to know how to test them. We're going to cover why database testing is essential. Things like data integrity and accuracy directly impact what users see and how well your app works. Let's dive into some key SQL concepts that SDETs need to understand, like CRUD operations, joins, stored procedures, and indexes. And finally, we will look at some common strategies for testing database interactions, like validating the data you insert or update and making sure you are protected from SQL injection. Okay, let's talk about ORM. It's a really important concept in software development, especially when working with databases. Think of it as a translator. It helps us work with data using objects in our code instead of writing complicated SQL queries directly. We're going to focus on two key players here, JPA and Hibernate. JPA is essentially the standard for how we do object relational mapping, and Hibernate is one incredibly popular implementation that follows those standards. Basically, entities represent your tables, mappings tell Hibernate how they relate, and repositories make it easy to work with data like adding, updating, or deleting records. Okay, let's talk about how the shift to cloud-native applications impacts software development, engineers, and testing. These apps are built using a lot of small, interconnected services, kind of like Lego bricks. This means testing isn't just about individual components anymore. It's about making sure everything works together smoothly under pressure. SDETs need to focus on things like how the system handles lots of users at once and what happens when one part fails. Using cloud platforms for testing lets us realistically simulate these complex scenarios, ensuring our applications are truly robust. Okay, let's talk about using Docker and Kubernetes for your SDET work. Essentially, these tools help you create super reliable test environments. Think of Docker as a way to package up everything an application needs: its code, libraries, and configurations into a self-contained unit called a container. These containers are lightweight and portable, meaning they run consistently across different systems. Then Kubernetes takes things a step further by orchestrating those containers. It handles scaling your test infrastructure automatically based on what you need, making sure you always have the resources available to run your tests efficiently. Using Docker and Kubernetes ensures your tests are isolated from each other, preventing conflicts, and guarantees that they'll produce the same results every time, which is crucial for reliable SDET work. Okay, let's talk about how SDETs are using containers to run their tests. Essentially, they're packaging up all the dependencies a test needs, like libraries and specific versions of software, into these little containers. Think of it like shipping your entire testing setup in a box. This makes sure that everyone on the team is running the exact same environment, which massively reduces problems caused by "if works on my machine" situations. Plus, containers are super scalable. If you need to run more tests simultaneously, you can just spin up more of them. And because everything's contained, they're really portable too. Moving a test between different servers is much easier than trying to replicate the environment manually. Okay, let's talk about managing our test data effectively. Sometimes creating enough realistic and diverse test cases can feel like a huge undertaking. That's where Faker and Mockaroo come in. Faker is a JavaScript library that generates all sorts of fake data: names, addresses, even phone numbers. It's super easy to use for getting started with basic synthetic datasets. But if you need really specific data tailored to your application, Mockaroo is the tool for you. Mockaroo lets you define exactly what kind of data you need, including fields, types, and distributions, basically creating custom data schemas. We can even generate it in CSV, JSON, or even SQL. It's a fantastic way to streamline your test setup process. Let's talk about unit testing frameworks. They're a cornerstone of SDET work. We have several popular choices, like JUnit for Java, which is super common. Then there's TestNG, which builds on JUnit and adds some really useful features. NUnit is the go-to for NET projects, and PyTest in Python is incredibly popular because it's easy to learn and very adaptable. It's great to get familiar with a few different ones to best suit your work. Okay, let's talk about code coverage. When we're building software, Code Istanbul is a fantastic tool for measuring how much of our code is actually being tested. It works by instrumenting the code during compilation, basically adding some tracking to tell us what lines get executed when tests run. It integrates really well with common build tools like Maven and Gradle, making it simple to add to your workflow. Your code then generates reports in various formats: HTML, XML, or CSV, showing you how much of the code is covered by your test suite. It's great for identifying the areas that need more testing attention. Okay, let's talk about static code analysis, specifically using SonarQube. Think of it like a really thorough code review, except it happens automatically. Static analysis means we're checking the source code itself without actually running the program. Tools like SonarQube help us find potential problems early on, bugs, security vulnerabilities, and even how easy it is to understand the code. SonarQube is super popular because it works across different programming languages and fits right into our continuous integration and deployment process. It uses rule sets, basically coding standards we want to follow, to look for issues like common errors or areas where the code might be complex. It also gives us a maintainability index, which tells us how easy the code is to understand and change. You can see an example of a simplified rule right here. It's all about looking for potential problems, like if a value is too high. Okay, let's talk about how Agile changes the game for testing. Instead of seeing testing as a separate phase at the end, it becomes an integral part of everything we do. TDD is a really popular approach. You write your tests first, which forces you to think clearly about what the code should actually do. Then there's BDD, where we use something called Gherkin to describe how our features are supposed to behave in simple, understandable terms. Think of it like writing stores for the software. And finally, SDET. That's all about automating tests as part of our build process so they run automatically whenever code changes happen. This means catching bugs super early and keeping everything moving smoothly. Let's talk about SDET and how testing fits into the bigger picture. You'll notice we're discussing shift left and shift right testing. Think of it like a spectrum, not a strict division. Shift left means bringing testing ** a layer * in the process closer to when you're designing and building things. This could involve writing tests before you write code, or using tools that automatically check your code for potential problems. Then there's shift right, which is about testing later on, integrating everything together and making sure it all works smoothly. That includes things like regression testing to catch any unintended side effects of new changes, performance testing to see how fast and stable the system is, and even getting real users involved in testing to make sure it meets their needs. Okay, let's talk about continuous testing within DevOps. As an SDET, you're really at the heart of this whole process. The core idea is to move testing *left*, meaning we get tests in as early as possible, close to the code itself. We're talking automated unit and integration tests alongside end-to-end tests. These all run automatically within your CI/CD pipelines every time someone pushes a change. The goal? Faster releases, better quality software, and less risk. Think of it like this: automated testing gives you immediate feedback on any issues as soon as they arise, helping everyone work together more efficiently. Okay, let's talk about how we actually show what happened during our tests. We use tools to create really clear reports, and today we're focusing on extent reports and their awesome integration with Allure. Extent reports are a great starting point. They give you lots of flexibility in terms of how your test results look, with charts and tables that make it easy to understand the progress. But to take things way up a level, we often use Allure. Allure is like a super-powered reporting engine that takes the data from extent reports, specifically its JSON output, and turns it into truly beautiful and interactive reports. It's all about making testing more transparent and easier for everyone involved. Okay, let's talk about keeping our SDET code neat. As an SDET, writing clean, readable code is absolutely essential. It makes it much easier for everyone on the team to understand what you're doing, especially when reviewing your tests or stepping through them during debugging. We want to focus on readability, maintainability, and testability. These are our core principles. Think about naming conventions. Descriptive names make a huge difference. Also, remember to organize your imports logically for easy navigation. And don't forget docstrings, they are super helpful for explaining what your code does. Okay, let's talk about how object-oriented programming fits into the world of software development, engineering, and test. Essentially, understanding OOP principles like encapsulation, abstraction, inheritance, and polymorphism can really level up your testing game. Encapsulation helps us organize our test components so they're neat and protected. Abstraction lets us focus on what's important without getting bogged down in the details. Inheritance is fantastic for creating reusable test cases based on common patterns, and polymorphism allows you to write flexible tests that can handle various scenarios with a single function. Okay, let's talk about how smart design can really improve our test automation. As SDETs, we don't want to rewrite the same code over and over again when facing similar situations. That's where design patterns come in. Think of them as helpful blueprints for building robust and reusable tests. We've got a few key ones like the page object model, which helps us organize our application interfaces into manageable objects, making maintenance much easier. Then there's the factory pattern, great for creating test objects dynamically so we don't have to duplicate code. The fixture pattern is vital for setting up consistent testing environments, and dependency injection helps keep things loosely connected, boosting testability. It's all about building a solid foundation for our automation efforts. Okay, let's talk about dependency injection, a really important concept for SDETs. Basically, it's all about making sure your tests aren't overly reliant on real external services. Imagine you have a test that needs to interact with an API. If that API is down or slow, your test will fail too. I help solve this by providing those dependencies like the API connection directly to your code instead of it having to figure them out itself. There are a few ways to do this: constructor injection, where you pass dependencies and through the class's constructor; setter injection, using setter methods; and interface injection, which is less common. The key takeaway is that SDE makes tests much easier to write, isolate, and maintain, especially when dealing with complex external systems. Okay, let's talk about dealing with errors, a really important part of being in SDET. Think of it like this: as a tester, you'll inevitably find bugs. But don't panic. The key is to be prepared and know how to handle them when they pop up. We'll cover two main areas: preventing problems in the first place through careful design, and knowing how to react when something does go wrong. We'll look at using try-catch blocks in code, which is a common way to gracefully handle unexpected errors. Also, it's great practice to use standardized error codes and messages so everyone understands what's happening. And then let's dive into some debugging techniques like logging, using your IDE debugger to step through the code, and really understanding those stack traces that tell you exactly where an issue is originating from. Reproducing the error consistently is also super helpful for isolating the problem. Ultimately, good exception handling and debugging makes our software much more reliable. Okay, let's talk about speeding up our tests. Multithreading is like having multiple testers all working on different parts of the same software at nearly the same time. It's all happening inside one program. Then there's parallel test execution. This is where we actually run multiple tests simultaneously, potentially across different computers or processors. Think about it as having a whole team testing everything at once. It can dramatically cut down on overall test time, which means faster feedback for the development team. We've got a quick example of how you might achieve this with Python's threading library using PyTest. Okay, let's talk about mocking and stubbing. They're super important tools for SDETs when dealing with API. Think of them as creating stand-ins for your actual API calls. Mocking creates a full replacement, including all the expected method calls, really useful for verifying interactions. Stubbing is more focused. It's providing predefined responses to specific requests, perfect for testing how your code handles different API outcomes. There are lots of tools available like Rakito and YMock that can help you build these stand-ins efficiently. Okay, let's talk about how we actually do testing within our continuous integration and continuous delivery pipelines. It's a really important part of the SDET role. Basically, when developers make changes to the code, commit them to something like Git, that triggers the CI system. The CI system kicks off the build process, which then runs automated tests. We're talking about things like unit tests, integration tests, and sometimes even UI tests, all run in a controlled environment. The results of those tests are automatically reported back, and as an SDET, you'll be looking at these reports to spot any problems early on. If the tests pass successfully, the pipeline moves on to deployment; otherwise, it's rolled back or stopped. It's all about catching issues quickly and ensuring we deliver high-quality software consistently. Okay, so let's shift gears a bit and talk about how we measure the effectiveness of our automated testing. It's really important to know if our automation is actually helping us build better software. We look at things like test coverage, how much of our code is being automatically tested. A good target is usually around 7 to -95%. Then there's the pass rate, which tells us what percentage of those automated tests are actually passing without any issues. Ideally, we want that to be really high, close to 98%. Of course, execution time matters too. We don't want our test suite taking forever to run. And finally, we track how many defects we're finding through automation before release. The more we find early on, the better. These metrics can fluctuate, so it's more about seeing an upward trend over time. Okay, let's talk about how we track bugs. It's a really important part of SDET work. We typically follow a life cycle. First, you report the bug. Then it sits in open, where it gets prioritized and assigned. Then, developers start working on fixing it, moving it to in progress. Once the fix is merged and tested, it goes to resolved, and finally, if everything checks out, it's closed. Now tools like Jira and Azure DevOps help us manage this process. While both are great for tracking issues, they have different strengths. Jira offers amazing customization but can require plugins for some reporting, while Azure DevOps is built in with strong integration into the development pipeline. It's about choosing the right tool for your team's needs. Okay, let's talk about how we estimate test effort in Agile. It's really different from traditional methods because we are working in short sprints. One popular technique is planning poker. It's a collaborative way to figure out how much work each story will take. We use the Fibonacci sequence, like 1, 2, 5, 8, and so on, to represent relative complexity. Another approach is t-shirt sizing. We roughly categorize tasks as small, medium, large, or extra large based on their estimated effort. You've probably heard of the bucket method too, simply grouping stories into buckets representing different levels of work. And finally, triangulation involves comparing a new task to similar ones you've done before to get an idea of how long it will take. The important thing is that these are just starting points, and we should keep refining our estimates as we learn more. Okay, let's talk about how the Agile ceremonies fit into an SDETs day to day. It's more than just writing tests. It's being a part of the whole process. During sprint planning, you're there to help estimate the time needed for testing and break down stories so they're truly testable. The daily stand-up is all about staying connected and spotting any roadblocks that might slow down your testing efforts. Then comes the sprint review. This is where you get to show off the awesome work you've done, including the results of your tests. Finally, the retrospective. That's a chance for everyone to learn and grow. And SDETs can really shine by suggesting ways we can improve our testing process. Let's talk about how we can really understand the value of test automation. It's not just about writing some scripts, it's about making smart investments in quality. We'll look at return on investment, or ROI. Basically, are we getting more benefit than cost? And then connect that to cost of quality, which is all the costs associated with preventing and fixing defects. Automation can help us reduce those costly failures and make sure we're proactively catching issues early. Let's talk about accessibility testing. It's super important to make sure your software is usable by everyone, no matter their abilities. We're going to look at Axpayload, a really handy tool for automated checks. Basically, it uses the WCAG guidelines. Those are like best practices for making websites accessible, and finds problems like missing alternative text on images or not enough contrast between text and background. Axpayload is easy to integrate with tools you might already be using, and it gives you detailed reports so you can fix any issues. I'll show you a quick example of how you'd use it with Cypress. If you want to dive deeper, check out Tech University. They have tons of great resources on accessibility. Okay, let's talk about code review and quality assurance, a really important part of being an SDET. It's not just about finding bugs, it's about building better software. As an SDET, you're essentially the champion for clean, reliable code. We want to catch problems early on before they become big headaches. Tools like Sonar Quebec can automatically flag potential issues, and we always have coding style guides to help keep things consistent across the team. It's a collaborative process where reviewers give feedback to authors, who then make changes. Really valuable for knowledge sharing and ensuring everyone's on the same page. Let's talk about UI UX testing. It's super important for SDETs. Basically, we want to make sure our apps are not only functional but also a joy to use. UI testing focuses on how the user sees things is easy to navigate. UX testing digs deeper into the feeling users get, are they efficient, and finding what they need. We'll look at some common techniques like usability tests, where we watch real people interact with our software, /B testing to compare different designs, making sure things are accessible for everyone, and even eye tracking to see exactly where users are looking. Okay, let's talk about testing GraphQL API. As an SDET, you'll want to understand that this isn't like traditional REST. GraphQL lets clients ask for exactly the data they need, which is really great for efficiency. The key things to know are queries. Those are your client requests for data, and mutations, which are how clients change information on the server. GraphQL also uses schemas, kind of like a contract that defines what's available. When testing, you'll want to make sure your schema is accurate, test your queries to make sure they return the right things, and verify your mutations don't cause problems. Tools like GraphQL are super helpful for exploring API directly. Basically, think about data precision and giving clients control. That's what testing GraphQL is all about. Okay, so let's dive into authentication, specifically OAuth and JWT. As an SDET, you're going to be looking closely at how these technologies secure user access. First, OAuth 2.0 is all about letting third-party apps use your data without you giving them your password. It's like a valet key. They can drive your car, but they don't get the keys to your house. Then we have JWT, which are essentially encrypted digital keys that carry information about the user and their permissions. As an SDET, you'll be rigorously testing these tokens for things like signature integrity, making sure no one has tampered with them, expiration times, and verifying the claims they contain match what's expected. You'll also want to ensure that if a token is revoked, it actually stops working immediately, and test against potential vulnerabilities like replay attacks. Okay, let's talk about a really valuable tool for any SDET specializing in mobile apps: cloud device farms. Basically, these are like massive collections of real iOS and Android phones and tablets that you can access remotely through the cloud. Instead of needing to buy and maintain your own lab full of devices, which gets expensive *fast*, you pay a vendor like BrowserStack or Sauce Labs to give you access to thousands of devices at any time. It's amazing for ensuring your app works flawlessly across different screen sizes, operating systems, and hardware configurations. The benefits are huge. It cuts down on costs significantly, allows you to easily scale your testing efforts up or down as needed, and gives you access to a truly diverse range of devices, something that would be nearly impossible with a local lab. Think about all the different manufacturers, OS versions, and screen resolutions you need to cover. It's just simpler with cloud farms. Okay, let's talk about infrastructure as code, a really important concept for SDETs today. Basically, we're treating our infrastructure like software. Instead of manually setting up servers and networks, we write code that describes the exact state we want. Think of it like writing instructions for a machine to build something. Tools like Terraform, Ansible, and AWS CloudFormation let us do this, and it has huge benefits: version control so you can track changes, repeatable environments across different stages, and complete automation which reduces errors and speeds up deployments. We can even write tests to make sure our infrastructure is exactly as we expect. Okay, let's talk about how we keep an eye on our software once it's live. As an SDET, knowing if things are running smoothly is incredibly important. We'll be looking at 3 key monitoring platforms: New Relic, Splunk, and Grafana. New Relic gives us a really detailed picture of how our apps are performing, things like response times and errors. Splunk is like a detective for logs. It helps us find clues about what's going on behind the scenes by collecting data from all sorts of places. And finally, Grafana lets us build beautiful dashboards to visualize that data so we can easily spot any problems or trends. Essentially, these tools are vital for identifying and resolving issues quickly, cornerstone skill for any SDET. Okay, let's talk about how different approaches to testing can really help us build better software. First up is BDD, behavior-driven development. Think of it as translating what the software should do into clear, understandable stories written in a way that everyone on the team, from developers to business folks, can grasp. Next we have TDD, which stands for test-driven development. This means you write your tests before you write any actual code. You build up your features by writing failing tests and then coding just enough to make those tests pass. Finally, there's acceptance test-driven development. It's a bit like BDD but specifically focuses on acceptance tests that are created collaboratively between the business team and developers. These tests really drive development, ensuring everything meets expectations. Okay, so as an SDET, you're a key part of ensuring software quality. We break down testing into different levels. It's like building something brick by brick, and each level checks a specific aspect. First up is unit testing. That's all about making sure individual pieces of code work perfectly on their own. Next, we move on to integration testing, where we see if these smaller units actually play nicely together. Then comes component testing, which tests larger, reusable parts of the system. And finally, end-to-end testing. This is like putting on a whole outfit and seeing how everything works as one complete user experience. Okay, so let's talk about how Docker Compose can be a huge help for SDETs when it comes to setting up our test environments. Basically, you define everything your tests need, like databases and web servers, in one simple file called Docker Compose YAML. Then, with just one command, Docker Compose up, all those containers get built and started automatically, creating a fully isolated environment for each test. This makes it super easy to replicate the same setup every time, which is critical for consistent results. Okay, let's talk about database migration testing, a really important part of the SDET role. Basically, when we make changes to our databases, whether it's adding new features or updating existing ones, we need to be absolutely sure that everything is working correctly and that no data gets lost along the way. We do this by carefully validating the data itself, running tests to make sure applications still work as they should, and doing regression testing to capture any unexpected side effects. Performance is also critical. We want to ensure the migration doesn't slow things down. Tools like SQL scripts and data comparison software come in handy here. Okay, let's talk about serverless application testing, a really interesting area for SDETs. Because these apps are built around functions that pop in and out of existence with each request, it changes how we approach testing completely. It's not just about individual units. You have to think about the connections between all those services. We'll cover some key considerations like the fact that functions are temporary, their distributed nature across different providers, and how event triggers need really careful design to make sure everything works together. Finally, we will also look at some effective testing strategies: integration tests to check the function's interactions, contract tests to ensure it follows its defined agreements, performance tests to see how well it scales, and security tests to protect against potential vulnerabilities. Okay, so let's talk about testing event-driven architectures. As an SDET, you need to make sure your system handles events correctly, that messages get delivered as expected and consumers process them reliably. A big part of this is understanding how message queues work and verifying that messages are delivered at least once, or exactly once if that's a requirement. Then, we need to check our event consumers. Do they handle incoming events in the right order? And what happens when things go wrong? Do they gracefully recover from errors? We also need to think about how events are correlated and sequenced. It's not uncommon for one event to trigger another, so you've got to make sure the chain of actions works correctly. Contract testing is a good starting point here, defining clear agreements between producers and consumers. Integration tests help us simulate these flows across different microservices, and chaos engineering, intentionally introducing failures, can really highlight potential weaknesses in the system. Okay, let's talk about getting really precise with locating elements on web pages. As SDETs, we don't always have simple ID or classes to work with. That's where XPath and CSS selectors come in. XPath is like a way of navigating through an XML document. It lets us jump around the entire page structure based on how things are related. We can start from the very top and drill down, which is really useful for deeply nested content. Then there's CSS selectors. They're basically shorthand for targeting elements based on their tags, classes, or even attributes. They're often faster than XPath and easier to read. Let's quickly compare them. XPath can be a bit complex when you need to go deep, while CSS selectors tend to be more straightforward. Okay, let's talk about Pact. It's a really cool tool for making sure your API works seamlessly together. Basically, Pact is all about contract testing. It helps developers and testers agree on exactly what an API should do before building anything. Think of it as a blueprint that both the provider of the API itself and the consumer, any application using the API, follow. The provider defines the contract, often in a standard like OpenAPI, outlining its capabilities. Then, the consumer tests those capabilities by sending requests to the provider and checking if the responses match what was promised. Patch Broker is an optional system that helps keep track of these contracts as they evolve. It's super helpful for larger projects. Okay, let's talk about what you might expect during your SDET interview, specifically when it comes to coding challenges. A big part of these interviews is testing your fundamental skills in algorithms and data structures. You'll often see questions centered around sorting problems like implementing bubble sort, insertion sort, or even merge sort. It's not enough just to write the code, you need to understand how efficient each method is too. Then their searching, linear search, and binary search are common. And of course, string manipulation is a frequent topic. Palindrome detection, reversing strings, and finding specific patterns within text. Don't worry if you don't know every single algorithm by heart. The key is to demonstrate your problem-solving approach and ability to think through solutions. Okay, let's talk about how Agile DevOps changes the game for quality assurance. As an SDET, your role is evolving beyond just finding bugs. You're a core contributor to building faster, more reliable software. We're focusing on shifting left, which means bringing testing into the early stages of development even when requirements are being defined. Think about automating tests alongside design and coding. The test automation pyramid helps us prioritize our efforts. We want a strong base of automated regression tests complemented by manual exploration at the top. CI/CD is critical. Your tests need to be integrated into this continuous build and deployment pipeline. And BDD, behavior-driven development, is all about writing tests *with your user stories, ensuring everyone's on the same page regarding what constitutes acceptable behavior. Finally, managing test environments through code ensures consistency and makes it easier to reproduce issues. Okay, let's talk about security, a really important part of SDET work. We're focusing on vulnerability scanning tools today. Basically, these tools help us find weaknesses in our code before they become problems. There are three main types. SAS scans your source code to spot issues early. DAS simulates attacks against a running app, and IAS combines the best of both worlds for real-time feedback. When choosing a tool, it's important to consider how well it covers different vulnerability types, its accuracy, avoiding too many false alarms, whether it fits into your workflow, and importantly, if it provides reports that are clear and easy to act on. Okay, let's talk about how testing fits into Agile projects. The Agile testing pyramid is a really helpful visual to understand this. At the very bottom, the widest part, are unit tests *. These are super granular tests that check individual pieces of code in isolation. As we move up, we get to integration and API tests. These tests how different units work together. And finally, at the top, we have UI and user acceptance tests. These are more exploratory tests focused on the overall user experience. SDETs play a critical role throughout this pyramid, especially in setting up unit tests and automating some of the higher level testing. Let's talk about how we can really dig into an application to find potential problems. We're focusing on exploratory and ad hoc testing today. Exploratory testing is like a detective. You're not following a script, but rather using your intuition and experience to uncover unexpected behavior. It's all about learning as you go, and often involves thinking aloud while you explore the software. Then we have ad hoc testing, which is like a quick checkup where you create tests on the spot based on what you're seeing or wondering about. These techniques are especially valuable when time is tight or you need to quickly verify something specific. Okay, let's talk about load balancing and how it plays a vital role in our SDET work. Basically, a load balancer distributes incoming requests across multiple servers. Think of it like a traffic cop for your application. For automation, this is really important because it allows us to simulate realistic user loads during our tests. Without it, we might only be testing one server, which isn't representative of how things work in production. This ensures we get comprehensive coverage and can verify that our system scales properly when demand increases. We can use techniques like simulating a large number of requests through HTTP client, ensuring the test accurately reflects real-world traffic patterns. Okay, let's talk about optimizing those test automation frameworks. It's not enough to just have a lot of automated tests, we need them to run quickly and efficiently. A big part of this involves breaking down your massive test suites into smaller, manageable modules. Think reusable components that you can use across different tests. Then, let's look at how we can manage our data more effectively, whether it's generating realistic test data or using database seeding. Also, parallel execution is key. Running multiple tests simultaneously dramatically speeds things up. And finally, don't forget about logging and reporting. Make sure you're getting the right information without overwhelming yourself with unnecessary details. Okay, let's talk about test harnesses. Think of them as your test environment's foundation, a reusable framework that makes building and running tests much easier. A test harness is really just code and data combined that handles the initial setup for your tests, like connecting to a database or setting up the right environment. It also includes scripts to clean things up afterwards, ensuring everything's back where it should be. Crucially, it manages test data so you have consistent data to work with. And finally, harnesses often contain reusable functions that handle common tasks, making your tests more modular and reliable. Okay, let's talk about how SDETs play a vital role in keeping our production systems running smoothly. Essentially, we're involved in the whole process of monitoring, from understanding what tools are being used, like Prometheus or Grafana, to actually defining those alerts themselves. It's not just about setting up some random alarms. We work with SRE and developers to ensure they are meaningful and focused on important KPI. And when an alert does fire, which it inevitably will sometimes, we're often the first ones on the scene, diving in to figure out what's going wrong and helping get things back on track. We also automate a lot of these monitoring tasks to make our lives easier and ensure consistent data collection. Let's talk about SDET, software development, engineering, test. It's a really exciting field right now because we're seeing more and more businesses relying on complex SaaS, CRM, and ERP systems. These applications are incredibly important, so ensuring they work flawlessly is key. But each one presents its own unique set of challenges, from making sure a cloud-based SaaS application can handle massive scale to verifying the accuracy of data within a CRM or getting an ERP system running smoothly across all business processes. Okay team, let's talk about making our tests super flexible, specifically using environment parameters. Basically, we all know that software behaves differently depending on where it's running: development, quality assurance, and production, for example. Instead of writing completely separate test scripts for each one, we can use parameterized approaches to reuse code and make sure everything's consistent. It cuts down on a huge amount of duplication, makes our tests much easier to maintain, and lets us quickly adapt them when new environments are added. Take this example: the database connection string is different in each environment, right? We can easily parameterize that value instead of writing separate test scripts for each one. Okay, let's talk about taking test automation to the next level, specifically how we orchestrate our CI/CD pipelines. It's not just about running tests, it's about creating a smooth, repeatable process that delivers quality consistently. We're moving away from scripting everything and embracing declarative pipelines, which focus on what needs testing rather than ***. Then, automated environment provisioning is crucial. We need to make sure our test environments are always consistent. Parallel execution allows us to run tests concurrently, massively speeding things up, and integrative feedback loops let us see the impact of changes immediately. Think about it as a well-oiled machine delivering reliable results. Okay, let's talk about logging. It's absolutely vital for any SDET. Good logging helps us understand exactly what went wrong when a test fails, and also allows us to spot trends over time. There are different levels of logging. Debug is super detailed, best used during development. Info provides general information about the test running. We want to use error and fatal for serious problems. And most importantly, be specific in your messages. Don't just say test failed, tell us which test failed, what step caused it, and any relevant data. Structured logging, using formats like JSON, makes analyzing logs much easier. Finally, remember to avoid logging sensitive information. Does that make sense? Okay, let's talk about mock servers. As SDETs, we often need to test our applications without relying on actual external services that might be down or slow. Setting up a mock server is a fantastic way to do this. It allows us to create artificial versions of those services, giving us complete control over the responses we get during testing. Why bother? Well, it isolates our tests, lets us simulate different scenarios like slow connections, and most importantly, speeds things up dramatically by eliminating external service delays. There are a bunch of tools out there. Postman is really popular because it's versatile. Macoun is super simple to use, and Mock offers a lot more power if you need it. Let's say we want to mock an API endpoint for users. We can set up a basic request in Postman, specify the method like get, the URL, and any headers, then define what our mock server should return, like a list of users with their ID. It's all about creating consistent and predictable behavior during your tests. And don't forget to document those configurations. It makes things much easier for everyone in the long run. Okay, let's talk about versioned API testing, a really important skill for SDETs. Basically, it's all about making sure our API are stable and reliable as they evolve. We need to test every change made to an endpoint in each new release. Why? Well, it helps us prevent unexpected bugs that might affect existing features, make sure our tests give us consistent results every time, and gives us a clear record of how the API changed over time. Super helpful for debugging. To do this, we use version control like Git alongside our test code, organize our tests by version, and ideally automate them with tools like Postman or Rest Assured. Okay, let's talk about WebSocket testing for SDETs. It's a really important area these days. WebSockets essentially create a direct line of communication between your application and the user without constantly needing to ask for permission like regular HTTP requests. This means that as an SDET, you need to focus on things like making sure connections are established correctly, messages are being sent and received properly, including checking their format, and crucially, how the application handles errors if there's a network problem or something goes wrong with the server. You'll also want to test how well it scales when lots of users are trying to connect at once. Tools like Postman, Charles Proxy, and even Selenium can be helpful here, but you might need some specialized approaches depending on what you're testing. Okay, let's talk about making our automated tests tougher, more resilient, and self-healing. The goal here is to avoid those frustrating situations where a single hiccup causes your entire test suite to crash. We want scripts that can bounce back from temporary problems like network glitches or changes in the environment. We'll explore strategies like gracefully degrading when components fail, using retries with increasing delays for intermittent errors, and dynamically skipping steps that might be unstable. Data-driven testing and avoiding hard-coded dependencies also help tremendously. Finally, don't forget good logging. It's your best friend when troubleshooting issues. Okay, let's talk about automating performance baseline checks, a really important part of being an SDET. Basically, we need to make sure our applications are running smoothly and consistently over time. Manually testing this would take forever and be super unreliable. So, the key is automation. We'll continuously monitor things like how quickly pages load, how many requests our system can handle, and how often errors occur. Setting up a baseline, which is basically collecting data when everything's running normally, helps us spot problems faster. Tools like JMeter or Gatling are great for setting up automated tests to do this. And finally, we need to get alerts set up so we know immediately if anything goes wrong. Let's talk about building blocks for our tests, specifically custom utility libraries. Think of them as little helpers that we can reuse again and again. The main benefit is reducing repetition and making our tests easier to maintain. We'll cover why creating these libraries is important, like how they boost reusability and simplify updates. Some common examples include helper functions for things like generating test data or interacting with API, page object models for representing user interfaces, and even assertion libraries that let us add extra checks beyond the basics. It's all about making our testing more efficient. Let's talk about how branching helps us keep our automation projects organized. It's not just about creating branches, it's about strategic branching. We use different approaches like Git flow, which is great for bigger teams and releases, or GitHub flow if we want a simpler, continuous deployment model. Trunk-based development is another option where everyone commits directly to the main branch, but that needs super reliable tests. When adding new automation scripts, always create a separate branch just for them. This way, you can test everything thoroughly without risking problems in your existing tests. Okay, so let's talk about keeping track of all that test data. It can get pretty overwhelming. As SDET, we need a solid way to manage our reports and make them accessible to everyone. That's where containerization comes in. Basically, we're packaging our testing tools like TestRail or Zephyr into self-contained Docker containers. This ensures that the way your reports look and function is consistent across different environments: development, staging, even production. It makes scaling up as your testing grows a breeze, and provides a fantastic level of reproducibility if you ever need to debug something or audit a report. Let's break down some key benefits: consistency, scalability, and reliability. Think about it like this: your tests run, they generate reports. Those reports are neatly packaged into a container, and then anyone on the team can easily access them via an API or web interface. Okay, let's talk about behavior-driven API testing. As an SDET, understanding how API should behave is key. BDD helps us do just that. It's all about defining what the API should do from a user's point of view. We use scenarios written in Gherkin, which is like a simple, readable language to describe those expected behaviors. Think of them as little stories outlining how a user interacts with the API and what they should get back. We can even use parameterization, like scenario outlines, to test multiple inputs at once. Tools like Cucumber make this process super manageable. Okay, let's talk about scaling our test infrastructure. As SDETs, we can't just focus on writing tests. We need to make sure we can run them efficiently, especially when new features are released. Cloud services like AWS or Azure give us the flexibility to scale up resources as needed. Containerization with Docker helps ensure consistent environments for our tests, and orchestration tools like Kubernetes let us manage everything automatically. Load testing tools are also important. They help us simulate real user traffic to find performance bottlenecks. Think about a big feature release without scalable infrastructure. Your tests could take forever. But with the right setup, you can run them concurrently and get feedback much faster. Okay, let's talk about distributed load testing, a really important part of SDET work. Basically, it's all about making sure your application can handle ton of users at once. Think about a flash sale or a huge product launch. Just adding more servers isn't always the answer. You need to see how they actually perform under pressure. We set up a system with multiple machines simulating user traffic. Then we monitor everything: response times, how many requests are being handled, and if anything is breaking down. Finally, we analyze all the data to spot any bottlenecks and understand where our application needs more resources or improvements. Thank you for watching.